In today's digital landscape, software systems power nearly every aspect of our lives. From online banking to e-commerce platforms, these systems are expected to be available 24/7. Any downtime or performance issues can lead to significant financial losses and reputational damage. This is where monitoring and alerting systems come into play. Monitoring and alerting systems act as the watchful guardians of your software infrastructure. They continuously collect and analyze data from various components of your system, providing valuable insights into its health, performance, and overall behavior. By tracking key metrics and detecting anomalies, these systems enable you to identify and address potential problems before they escalate into major incidents. Imagine a scenario where a critical database server experiences a sudden surge in traffic. This surge could lead to slow response times or even complete outages, impacting users and business operations. A well-designed monitoring system would detect this unusual traffic pattern in real time and trigger an alert, notifying the appropriate team to investigate and mitigate the issue. Effective monitoring and alerting go beyond simply detecting problems. They empower you to make informed decisions about your system's capacity, performance optimization, and resource allocation. By understanding historical trends and usage patterns, you can proactively scale your infrastructure, optimize code, and ensure a seamless user experience. A robust monitoring and alerting system comprises several interconnected components, each playing a crucial role in ensuring the reliability and performance of your software infrastructure. Let's delve into the key components. First, we have metrics collection agents. These agents are deployed across your infrastructure to gather various metrics from different components. They collect data points such as CPU utilization, memory usage, network traffic, disk I/O, and application-specific metrics. The collected data forms the foundation for monitoring and analysis. Next, we have metrics storage and time series databases. Once collected, metrics need to be stored efficiently for historical analysis and trend identification. Time series databases are specifically designed to handle time-stamped data, making them ideal for storing metrics. Popular choices include Prometheus, InfluxDB, and Graphite. Then, there's the alerting engine. This component processes the collected metrics against predefined rules and thresholds. When a metric breaches a defined threshold, the alerting engine triggers an alert, notifying the designated personnel or systems. Alerting engines can be configured to send notifications via various channels such as email, SMS, or dedicated monitoring dashboards. Visualization and dashboards are next. Visualizing metrics is crucial for gaining insights into system behavior and identifying trends. Monitoring dashboards provide a centralized view of key metrics, often in the form of graphs, charts, and tables. They enable you to monitor the health of your system at a glance and quickly identify areas that require attention. Lastly, we have notification and incident management. Once an alert is triggered, it needs to be routed to the appropriate team or individual for action. Notification systems ensure that alerts reach the right people promptly. Incident management tools help track and manage alerts, ensuring that issues are addressed efficiently and resolved in a timely manner. Designing an effective monitoring and alerting system is an iterative process that involves careful planning and consideration of your specific needs and infrastructure. Here are the key steps involved in designing a system tailored to your requirements. First, define monitoring goals and metrics. Start by clearly identifying your monitoring goals. What aspects of your system are most critical to monitor? Which metrics provide the most meaningful insights into the health and performance of your application? Defining clear goals and identifying key metrics will guide your design choices. Next, choose the right tools. The monitoring and alerting landscape offers a wide array of tools, each with its strengths and weaknesses. Consider factors such as ease of use, scalability, integration capabilities, and cost when selecting tools for your system. It's essential to choose tools that align with your technical expertise and budget. Then, establish alerting thresholds. Setting appropriate alerting thresholds is crucial to avoid alert fatigue and ensure that notifications are meaningful. Analyze historical data to establish baseline metrics and set thresholds that accurately reflect abnormal behavior. Avoid setting thresholds too low, as this can lead to false positives, or too high, as it may result in missed incidents. Implement a layered monitoring approach. A layered approach to monitoring involves collecting metrics from different levels of your infrastructure, from the application layer down to the hardware level. This approach provides a comprehensive view of your system and helps pinpoint the root cause of issues more effectively. Lastly, design for scalability and resilience. As your system grows, your monitoring and alerting system needs to scale seamlessly to handle the increasing volume of data and traffic. Consider using distributed systems and cloud-based solutions to ensure scalability and high availability. Implement redundancy to prevent single points of failure. Monitoring and alerting systems are typically structured in layers, with each layer focusing on a specific aspect of your infrastructure. Understanding these layers is essential for designing a comprehensive and effective monitoring strategy. The first layer is infrastructure monitoring. This layer focuses on the underlying hardware and infrastructure that supports your application. It includes monitoring servers, networks, storage devices, and other physical or virtual resources. Metrics collected at this layer include CPU utilization, memory usage, disk space, and network latency. Next, we have application performance monitoring, or APM. APM tools provide deep insights into the performance of your application code. They track metrics such as response times, error rates, database queries, and external API calls. APM tools help identify performance bottlenecks and optimize code for better efficiency. Then there's user experience monitoring. While infrastructure and application metrics are essential, ultimately, the user's experience matters most. User experience monitoring focuses on metrics that directly impact the end user, such as page load times, transaction success rates, and overall application responsiveness. Finally, we have business activity monitoring, or BAM. BAM takes monitoring a step further by correlating technical metrics with business KPIs. It tracks metrics such as order volume, revenue, customer churn, and other business-critical data points. BAM provides a holistic view of how technical performance impacts business outcomes. Section 5. Connecting and scaling your system. As your infrastructure grows, connecting and scaling your monitoring and alerting system becomes increasingly important. Here are some strategies for ensuring scalability and seamless integration. First, use a centralized logging system. Centralized logging systems aggregate logs from various components into a single location. This makes it easier to search, analyze, and correlate logs from different sources, aiding in troubleshooting and root cause analysis. Popular centralized logging tools include Elasticsearch, Logstash, and Kibana, also known as the LK Stack and Splunk. Next, implement a message queue. Message queues facilitate asynchronous communication between different components of your monitoring system. This decoupling allows components to scale independently and handle spikes in traffic without impacting other parts of the system. RabbitMQ and Kafka are widely used message queue systems. Then, leverage cloud-based monitoring solutions. Cloud providers offer managed monitoring and alerting services that simplify deployment and scaling. These services often integrate seamlessly with other cloud offerings, providing a comprehensive monitoring solution for cloud-native applications. Lastly, automate deployment and configuration. Infrastructure as code tools such as Terraform and Ansible enable you to automate the deployment and configuration of your monitoring system. This ensures consistency across environments and simplifies the process of scaling your monitoring infrastructure. Section 6. Operational excellence running your system in production. Once your monitoring and alerting system is deployed, ongoing operation, troubleshooting and maintenance are crucial for ensuring its effectiveness and reliability. Establish on-call rotations and escalation procedures. Define clear on-call rotations and escalation procedures to ensure that alerts are addressed promptly even outside of business hours. Use tools like PagerDuty or OpsGenie to manage on-call schedules and automate alert routing. Regularly review and update alerting rules. Alerting thresholds and rules should be reviewed and updated periodically to reflect changes in your system's behavior and traffic patterns. Continuously fine-tune your alerting rules to minimize false positives and ensure that alerts remain relevant. Conduct root cause analysis for major incidents. When major incidents occur, it's essential to conduct thorough root cause analysis to identify the underlying reasons and prevent similar incidents from happening again. Use monitoring data and logs to retrace the steps leading up to the incident and identify areas for improvement. Implement automation for routine tasks. Automate routine monitoring and maintenance tasks such as log rotation, data backups, and system health checks. Automation reduces manual effort, minimizes the risk of human error, and frees up your team to focus on more strategic initiatives. Section 7. Building your own monitoring system, a practical guide. While numerous commercial monitoring solutions are available, building your own system can provide greater flexibility and customization. Here's a practical guide to get you started. Choose a programming language and framework. Select a programming language and framework that aligns with your team's expertise. Python with Flask or Django is a popular choice for building web-based monitoring dashboards. Select a time series database. Choose a time series database that meets your storage and query performance requirements. Prometheus and InfluxDB are excellent options for handling time series data. Implement metrics collection. Use libraries or agents to collect metrics from various components of your system. Prometheus exporters are available for a wide range of applications and services. Develop alerting logic. Write code to define alerting rules and thresholds based on the collected metrics. Use libraries like Alert Manager to handle alert routing and notifications. Create a web dashboard. Build a web-based dashboard to visualize the collected metrics using charting libraries such as Chart.js or D3.js. Your dashboard should provide a clear and concise overview of your system's health and performance. Section 8. Testing and deployment strategies. Thoroughly testing and deploying your monitoring system is crucial for ensuring its reliability and accuracy. Unit testing. Write unit tests to verify the functionality of individual components, such as metric collection scripts, alerting logic, and data processing functions. Integration testing. Conduct integration tests to ensure that different components of your monitoring system interact seamlessly. Test the flow of data from agents to the database, alerting engine and dashboards. Load testing. Simulate realistic traffic patterns to assess the performance and scalability of your monitoring system under load. Identify potential bottlenecks and optimize performance accordingly. Deployment strategies. Consider using blue-green deployments or canary releases to minimize downtime and mitigate risks during deployments. Gradual rollouts allow you to monitor the new version of your monitoring system and identify any issues before they impact the entire infrastructure. Section 9. Mastering monitoring and alerting, your path to reliability. Mastering monitoring and alerting is an ongoing journey that requires a deep understanding of your systems, continuous learning, and a commitment to operational excellence. By embracing a proactive approach to monitoring and leveraging the right tools and techniques, you can ensure the reliability, performance, and resilience of your software systems in today's demanding digital landscape. Remember that effective monitoring and alerting are not merely about reacting to problems, they empower you to anticipate, prevent, and resolve issues before they impact your users and business operations.